Hi and good morning. My name is Jonathan Bailey and I'm the editor of Health Estate Journal, the IHEM magazine. Welcome to this webinar in association with HEJ. The title is Using a UPS as a Secondary Source for Safety Services, and it will be presented by Alex Ems, Technical Director for Kohler Uninterruptible Power, who has over 30 years experience in the UK power protection sector. Kohler Uninterruptible Power says that with growing restrictions on generators, the use of UPS systems in healthcare buildings to support life safety systems is becoming increasingly important. In his presentation, Alex will discuss the various standards, regulations, and guidelines related to the installation and maintenance of such systems, how the type of load may affect the system, and additional considerations such as fault clearance. Engineers will learn how to determine which life safety system related regulations and standards apply to their application, why a UPS may now be the preferred secondary source, factors such as load type to consider, and how and why a UPS may be required to react differently to faults in these applications, what to consider when choosing the battery component of a UPS system, how to design for easy installation and maintenance, what to look for in a UPS supplier, and what a successful compliant UPS installation looks like. Alex has 23 years service at KUP, having initially joined the company as a field service engineer, progressing to senior engineer, supervisor, service manager, operations director, and now technical director. If you have any questions as the webinar progresses, please type them into the panel on the right of your screen, and at the end of the presentation, Alex will answer as many of the questions as time allows. I'm sure you'll find this an informative and valuable session. All attendees at today's webinar will be receiving a follow-up survey for their feedback, which Kohler UP would be grateful if they could complete. Over to you for what I'm sure will be a fascinating presentation, Alex.
Okay, thank you very much, Jonathan, and I appreciate the introduction. Yeah, so I'm Alex Ems. I'm technical director at KUP. I've been in the industry quite a while, and fortunate to be have various positions in Kohler Uninterruptible Power. But today we're going to go through a number of things, and during the presentation I'll be turning my camera off so you don't have to look at me the whole time, and we will return this back on at the end of the webinar for all the questions. Like John said, please do put questions in. It's great to have that interaction. We are going to go through a number of things. As we said, we're going to have a look at why UPSs are being used after a brief introduction to Kohler and KUP. We look at some of the standards around the safety guidelines, how it's installed, fault clearance in accordance with BS 7671, and look at the types of loads we are looking at for life safety, the batteries, installation and maintenance, as Jonathan said. Okay, so Kohler, as a company, we were originally founded in 1997 as Uninterruptible Power Supplies Limited, UPS AL. We were very successful and brought in the first transformerless modular UPS into the market in the UK and Ireland in 2001. And with that success, we was acquired by Kohler in 2008 as part of Kohler Company, which allowed us to make investments and open offices in Singapore by a company in Ireland we was working with, Pure Power, in 2017, and then rebranded as Kohler Uninterruptible Power in 2019. Being part of that Kohler Energy Group, we celebrate 100 years with the Kohler Energy Group. And now this year, Kohler Energy is set up as a standalone business, supplying all kinds of energy systems. As a company, KUP, we obviously now got a lot of experience, a lot of UK employees as well as employees around Singapore and Ireland, a large install base. And one of the things that we're very keen on is very high customer appreciation. So we survey our customers and we get a good NPS score from all of those, and that's, we're very much a maintenance company. We don't just want to sell equipment, we want to service that customer and equipment for the lifespan of the equipment and beyond, hopefully. So we got lots of experience in various applications. A lot of them originally, data center finance market, but now we are looking at all kinds of industries that need the power on 24/7, and this, including the hospitals and all the other safety systems that go alongside that. We have a complete power suite of UPSs. We're very well known for our modular range, and we got 10, 20 kilowatt modules, 50 kilowatt, 100 and 250 kilowatt modules, giving us a very good platform to build with. We also do the small and large standalone units, from small single phase up to very large three-phase standalone units, with all the various battery technologies available to fit onto these systems. Part of the safety systems, we do have central emergency lighting inverters purely for the emergency lighting. That covers, again, single phase, three-phase, modular. And like I say, we're very, very keen on our service and repair systems. We want to install, commission and support our customers throughout the lifetime of that unit. So along with the service, we do maintenance and audits. We do the design, installation, commissioning. We maintain and replace all the batteries and consumables. We can remote monitor all the systems on site, along with all the repairs, upgrades, and if necessary, any higher systems. Along with this, we also do lots more CPDs and training in the industry, hopefully to educate our customers in design and operation of UPS systems. So we're going to have a look at UPSs being used for life safety services, and obviously in the healthcare industry, we're very aware of the requirements for life safety systems under the HTM guidance for operating theatres and critical care. But there are other safety services that are required in buildings and residential areas and things like that. And this is where we're seeing the UPSs being used a lot more. So obviously, we need a secondary supply. The main one to have, if possible, is a secondary mains supply. And then we have the life safety generators, which again is the next best option if we cannot use, we haven't got a supply, or we need and we can't use the generator, then we will look at using a UPS. Now this is, when installed and operated correctly, is a very viable alternative. So that is very important, that it has to be installed and operated correctly. Okay, and we've seen a lot of systems not being done that way, and hopefully these sort of guidance and the education and the working with guidelines and standards, that we're trying to change that and make sure it's addressed and we fit a nice safe system. So the different standards and regulations we have, of course, we've got BS 7671, we have 8519, which is for selection, installation of fire resistance power control cables and systems for life safety. 9991, fire safety in residential. 9999 for fire safety in buildings. We've got 50171 for central power systems, and we've got 62040 for UPS. Now there are obviously other individual regulations covering individual life safety systems, which probably will need to be looked at as well. So if we look at 7671, 18th edition, it does talks about safety services. It gives us an example of them: emergency lighting, pumps, fire lifts, evacuation lifts, medical systems, smoke extract, all these things. If any system, it says it's not exhaustive, it's any system that protects life and property. Okay, so that's a safety system. So it can be very wide range of equipment that needs to be supported now. So it says for safety services, it's required to operate in fire conditions. You have an electrical source for safety supply that is to maintain for the supply of adequate duration. Okay, and that equipment shall be provided either by construction or erection to have fire resistant protection for the adequate duration as well. Okay, So the safety source is generally a secondary supply in addition to the normal source. Now, obviously, in a lot of healthcare situations, we have that, but there are obviously a lot of examples where that secondary source needs to be supplied, and we have to do that using storage batteries, primary cells, generator set specifically for the life safety, or a separate feeder, if possible. Okay, not often available nowadays. So it also talks about the central power supply sources. It says the battery shall be vented or valve regulated magnet free, according with the relevant standard, or for the NICAD, again, to the appropriate standard. So we can't just stick any batteries in, they do have to meet a certain standard. We should be designing the battery in stores for 20 degrees and should be design lives of 10 years as well. But a lot of the regulations aren't doing enough to specify around the battery systems. Now in 7671, the only place you'll find uninterruptible power supply written is under the safety systems in chapter 560, and it talks about where an uninterruptible power supply is used, it shall be able to operate the distribution circuit protected devices and start them when it's in an emergency condition running from inverter on battery. Okay, so like in island mode, no mains available, we have to be able to trip the distribution and start the devices. Okay, the batteries have to comply with the relevant regulation, and the UPS must be built to standard 62040 part 1 and 3. Okay, so it's quite specific. It also says that that safety service should be monitored to know that it's available to be used when required. So to summarize, we can use a UPS as a secondary supply. It must be able to operate those downstream protective devices, start the devices on battery with no mains, batteries to the relevant standard, UPS to the relevant standard, and monitored. Obviously, for medical supplies, we have the additional parts in 7671, and also for healthcare, we have the HTM 0601, which tends to follow the 7671 in a lot of ways. Okay, so one of the regulations that was updated not too long ago, BS 8519, is causing us to have a lot of discussions with customers. And it talks about the installation of a UPS equipment or battery inverter to be used as a power supply, as a secondary source, as for life safety, okay, as an alternative to a generator or second supply, okay. And it has an Annex A has been added, and it talks about Annex S a lot and refer to that for technical guidance on the selection and specification of UPS and batteries. So that annex is very helpful, okay, and it's referred to in other regulations. So this is around selection and specifying that UPS and some of the considerations we have to make, okay. It talks about, an alternative secondary source. It's generally conventionally a standby generator, but it can be used as a UPS, and according to 9991, if we look at, okay. So to summarize what the Annex A talks about, is it talks about the battery autonomy must be sized correctly and recharge time should be considered, because we have seen people just buying off-the-shelf UPSs with a short autonomy, saying, well, I've put a UPS on it as life safety, it's fine, when it isn't. We have to consider the recharge time, we'll talk about that. The UPS must be able to handle all the startup currents, we'll look at that. Lock rotor currents for motors. Being able to operate the downstream protective device, very important, and this is very familiar, hopefully, in a healthcare environment, when we do use UPSs for those medical critical areas. If we're feeding lifts, we might have regen lifts, we have to consider it. And we should consider where the UPS is installed and operated environmentally. And this is, again, along with the maintenance, something that we have seen over the last few years. People are installing UPSs in bad environments and not maintaining them. So the regulations are catching up to help us with this. It talks about the different battery technology. the VRLA, NICAD, Plant A, lithium-ion, but recommends that VRLA is the most cost-effective, and we tend to agree that. But we must operate it, as it says, at the optimum 20 degrees for the best life expectancy and performance. Okay. The UPS needs to be in the right environment and not overheat on a mains fail, because if it's a 3-hour discharge time, we want to make sure the environment is kept so the UPS doesn't trip on over temperature. Okay. It refers to other regulations such as BSEN 12101-10, and this is where it calls for a standby generator. Okay, with a fuel tank of 4-hour, 8-hour, or 24 hours. And obviously with a UPS it's different, and it's very difficult for people to understand, how to correspond between fuel and the UPS battery. Okay, and that is a difficulty at the moment because regulations haven't caught up. Okay, so 8519 does give us good guidance on selection of UPS and battery, and it is referred to in other regulations such as 9991 and 9999. Okay, so 9991 for the power supplies, cable and installation of UPSs, it does talk about where dual supplies are recommended by the standards. The primary fuel should be generally taken from the public electricity supply, from a generator or an uninterruptible power supply, okay, or battery. So it specifically says you can use a UPS as a secondary source, and it must be sufficient capacity to do the required load. Okay, so quite clear. 9991 specifically says yes, you can use a UPS, but it does say refer to 8519 for guidance. Understandable. Okay, 9999 hasn't been updated recently, and it talks about a secondary power supply. For example, an automatically started generator or supply from another substation. It must be sufficient capacity to maintain in operation for at least 3 hours. All the smoke extract, the fire rescue comms, and other fire protection equipment. Okay, and it should be available within 15 seconds. All right, so it does say it shall have a changeover device automatically to transition between the normal mains and the secondary power supply, and it should be provided for sprinkler pumps, riser pumps, lifts, smoke extract, all those things. Okay, now G2.2 of this regulation says power supplies for lifts. Again, a secondary power supply such as a generator or supplied from a separate utility, meeting the recommendations in BS 8519, where a secondary supply is specified for other life safety systems, and it should be adequate capacity and used to supply the evacuation lift. So for 9999, it states the criteria for second power supply, which a UPS can fulfill. It gives generators as an example, but does not exclude a UPS, and it actually says to doing guidance in accordance with 8519, which talks about how we're going to install a UPS correctly. All right. So 50171. Now this often causes some confusions because this is a central power supply system, and it is intended to for energizing emergency escape lighting. Okay, in the case of a failure of a normal supply, and it says it may be suitable for energizing other essential safety equipment. Okay, as all the other equipment we've seen. Okay, it doesn't say you have to use it. Okay, so it is intended for emergency lighting. It's a very good standard and has some very good recommendations for that other regulations don't actually put in. Okay, so it does, it does say you can use it, but if you're using it for non-emergency lighting secondary supply, you don't necessarily have to comply with 50171. Okay, and if you want any further reading, the BISRIA BG70 gives a very good breakdown of the standards around the selection, around life safety and things like that. So worth a look as well. Now, if we're not going to be using a generator, how do we put in a UPS? Now, a generator obviously is a standalone system, doesn't need a supply as such, whereas a UPS needs a constant supply to keep the batteries topped up and charged. When the mains fails, that will put an output out and feed the secondary supplies it needs to. So typically with UPS, it's going to be centrally quite often. So that's going to be in an installed protected environment, protected for the time that the UPS is going to run for. The cables coming out of that environment obviously going to be rated and stored as in accordance with 8519, and that comes to local changeover panels, to local to the final circuits, where it's going to change over from the mains to the secondary source as required in an event, in an emergency. And those changeovers need to be rated to the right EN standard as well. Now, hopefully standards get better, because we do have changeovers in the UPS that could be used at some point. So we're putting a UPS in, and now we have to clear fault clearance in on UPS in accordance with 7671. This is quite hopefully familiar for those who are working on the critical medical areas, because this is the same thing. Okay, so where UPS is used, we must be able to operate distribution circuit protective devices, okay, downstream. So what we're talking about here is we've got the UPS feed and output board with various number of life safety loads, and if we have a fault downstream from that on a final circuit, we must be able to operate the actual protective device here to make sure that all the other loads continue to operate. Yeah, we don't want the UPS turning off, because that would turn off all the life safety loads. Okay. If we do have a fault here, it does say that any downstream output protective device should be able to be cleared. But if we lose that one, we're going to lose all of it. Yeah. So does it really need to trip this device if we have a fault here, or can the UPS just turn off? Alternatively, does this actually need to be a protective device? Okay. So, when we have a one circuit here, if there is no other circuit connected, if we have a fault anywhere, does it need to operate, or can we just turn the UPS off? And this is where some of the regulations are pointing towards, of having one UPS per load for life safety. Okay, so if there's a problem downstream, the UPS just turns off and makes things safe. Now, of course, if we use a UPS centrally, we've got several boards on it, and some people do want to put non-life safety systems on them. If we have a fault occur here on this circuit, we need this device to operate to ensure that all the life safety loads continue to run. Okay, it is very critical that we're able to trip that protected device. MCBs on the final circuits tend to be quite small and operate relatively easy. It's not always easy on UPS, but these sub-main devices get a little bit trickier to operate. And of course, if we have two or multiple life safety boards on a central UPS, then any fault anywhere needs to be able to isolate and maintain the rest of the circuits. Now, these sub-main breakers tend to take a lot longer to trip than MCBs. MCBs we could trip 10 milliseconds. These could be 80 milliseconds or more to trip. Now, if you've got life safety system or computers on it, there may be an interruption on those, because we are tripping that circuit breaker maybe take 80 milliseconds to trip, and that could cause an interruption. Something to be aware of. We might not want to mix loads, okay, on the UPS. So how does the UPS react to downstream fault? The UPS is made up of mains to the booster inverter feeding the critical load. So if we have a short circuit on the output, we have limited fault capability on the UPS. The inverter is an electronic device. We've got limited fault current, maybe 2 to 3 times the nominal current for maybe 40 to 200 milliseconds. The bypass supply, if available, is mains and much higher capability, maybe 10 times the nominal current for 10, 20 milliseconds. So how does the UPS decide what to do? This is quite generic for different UPSs. Firstly, it decides if it's over or under 150%. Most UPSs can run 150% up to 150% as an overload, okay, which means it's going to put output voltage. Above 150%, it has to protect itself and current limit, okay, which we would class as a short circuit. So if the fault is under 150%, then we will use the overload capability to trip the distribution device if possible, okay? And if it does, great, everything returns to normal, comes out of overload. If it doesn't, it treats it the same as a short circuit, and it says, is the bypass available? Is the mains available? Because if it is, that's much more powerful than the inverter. Let's go to bypass, use that to trip the downstream protective device, and hopefully return back to load on inverter after that's done. Now, if it still can't clear the fault using the mains, something has to give. So either the bypass protection in the UPS or the upstream protection needs to clear to make things safe. Now, if that bypass isn't available, this is where the inverter goes into a short circuit current limit, and it will put out its maximum, maybe 2 times or 3 times the nominal current. So it's quite low, okay, for very little time. And it will use that to try and clear the fault. If it does, it's great. The inverter comes out of current limit, everything goes back to normal. If not, typically the inverter will turn off at some point, and different manufacturers do it differently, okay? Now, for a life safety system, okay, we cannot rely on the mains being available, okay? If we're in an emergency situation, 7671 says we must be able to do it in off battery, so no mains. So we have to make sure that the inverter can trip the downstream fault and then return to normal operation to keep the remaining load running. Because if it doesn't, it's not compliant, okay? So that means that we have a short circuit on the output, the load must be fed from the battery, and the device trip in a required time. Other part of the regs say it must also be able to start up the connected loads without using the bypass. Okay, so yeah, there's a lot more to go in onto this this subject. We've done lots and lots of testing with different circuit breakers and MCBs, so we're very confident of what we can do, because everything works differently on an inverter as it does on mains. Okay, because we need to make sure that we put a big enough inverter to operate those devices, not using the bypass. So, you know, it's quite often we have to put a much bigger inverter in or UPS in to do that. We should be using the smallest, fastest circuit breakers we can in the distribution, so we can limit the size of the UPS you need to buy. Okay, but it very much speak to the manufacturer and be comfortable that they can size it accurately and tested it. Okay, so the types of load we look at in life safety is very different to a normal application for a UPS. We have to be able to start those safety devices on battery when required. Okay, so you know what are we going to do? You know, we have high inrush currents. So what we might want to do is make sure the inverter A can start them, but you know, stagger the loads coming in, you know, time them to come in, not all at the same time. That will reduce the size of the UPS. Understand what type of lift we have, because it could be regenerative. Any of the loads we have, sprinkler pumps, riser pumps, lifts, smoke extract, they're all motors. And if they're they're not turned on carefully, you know, we're going to get high startup currents and things coming from these motors we have to be very wary of. There's a lot of low power stable loads, that's fine, no problem. And this is just easy to calculate, we know the load. Then we have emergency lighting, obviously very variable, different LEDs, different drivers, very different. The medical systems in there, again, different IPS transformers. But then you have other things like scanners, which are very strange demand, often pulsing current regularly. So very difficult to size for the UPS maximum size, and also for autonomy because the loads vary all the time. Okay, so we have to look at them and be very sure we're getting it right. The lifts, there's obviously effectively two types of lifts for life safety. There's the evacuation lift and the firefighting lift. Now, the evacuation lift is purely there to evacuate the building and then not be used. So it's up to the designers to say how many operations of that lift are going to be required, to evacuate the building. So we have the maximum autonomy of the UPS waiting for the lift to be used and the number of operations. But then we have a firefighting lift that is used throughout the event. So typically that was going to be generally fully rated for the full autonomy of the event that we need to do, 1 hour, 2 hour, 3 hour. And we need to understand fully how those lifts are supplied. Do they have a soft start? Do they have regenerative braking? Do they have DC braking? Because that will affect the type of UPS that we use to feed it. Some loads, like sprinkler pumps, these regulations are catching up. Sprinkler pumps can be fed from individual UPSs, and this is where we don't need an ATS at the end, because we've got one UPS, one pump. So if the pump has a problem, the UPS has a problem, we just use the other one. Okay, so different regulations will require different things, but this is where we need them to catch up. Okay, so where we do have the motor loads, we need a certain amount of information to be able to size that inverter, that UPS. Okay, so all the information is recommended in 8519 that we need to be able to size that correctly. Okay, difficult to get, but very, very different. Yeah, very, very important that we do have it, so we can make sure we size it absolutely correctly. Okay, so batteries, again, lots of different types, different resilience, different autonomies. Got to consider the recharge, end of life, monitoring and managing of these batteries. Okay, so Annex A of 8519 does talk about this. It talks about VRLA, NiCad, plantate, lithium ion, but it does recommend that the most cost effective is the VRLA. Okay, and this is very much because these batteries are tend to be a long autonomy, whereas the other technologies, especially lithium and that, are in their element when they are for short, fast discharges on a regular basis. And obviously, a life safety system is going to sit there, hardly being used except for testing, hopefully, and then have a long, slow discharge. And that's where the lead acid is a good battery and very cost effective against the other types. Okay. Now, 50171, like I said, does have some other information in which is important, because it talks about as a guidance, central power systems should use a battery that has a declared life expectancy of 10 years at 20 degrees. A lot of the other regulations don't talk about this life expectancy. There's a lot of UPS batteries that are 3 to 5 year batteries. It's not really cost effective, and you're replacing them often. So having a 10-year plus battery is actually the right thing to do. It's much more cost effective over the lifespan and tends to be a more robust battery if you keep it at 20 degrees. Okay. Now the battery can be considered a weak point in any UPS system. Now most of the time it's only a weak point because it's not looked after, maintained, or tested. Okay, but we can improve the resilience of the battery by adding redundant strings. The HTM's guidance talks about this, having some extra resilience in the battery string. But a lot of other regulations don't do that. Okay, but it's worth considering. It's for life safety. If we have an extra string, we might not have the full autonomy, but we'll have some, and that might make a big difference. Okay. It also means if designed properly, we can take off part of the battery for maintenance or repair, leaving some battery available. Okay. Now, what battery autonomy do we need? Different regulations have different requirements, and it is up to your application and the regulations you are using to be able to define that. So, 8172 for lifts, typically 2 hours. 8519, 2 hours. But there's some smoke and heat control systems that part of it needs to be maintained for 72 hours. Now that might well be a case you put a separate battery in for that part, just running that part, and then have the UPS for the minimum standby times. Again, it talks about generators being available in fuel tanks and things like that. Okay, again, hasn't caught up. So you have to make that decision of how long it needs to be. All right. Double nine talks about a sufficient capacity to maintain an operation for at least 3 hours. Okay. Then you have the emergency lighting, which is 1 hour or 3 hour, depending on if you're going to evacuate the building or not. Okay. Now that's very important to talk about this. You know, are we going to evacuate a building, or when can we go back in? Okay. 50171 talks about having the batteries recharged to 80% in 12 hours. Okay. We need to consider that recharge time of the batteries. If we are going to do a full discharge test every, maybe once or twice a year, we have to make sure that that battery is recharged before we can enter the building. Otherwise, we haven't got the battery. It's not like a generator that can just be refueled, or the tank twice the size to have that time. So we have to consider that, and it's not often considered. Okay. So another thing that isn't specified a lot of places is a battery will age. Okay, so if it's a 10-year battery, it's designed to lose 20% over its lifespan of 10 years. So if we started with an hour, we're not going to have 1 hour at the end of life. Okay, so if we still want the autonomy, which we should have at the end of life, the battery has to be oversized by 25% at day one, so that when it gets to the end of life, it's lost 20% and we're at the required autonomy. Okay, it's not written many places. A lot of people don't consider it, but really this is life safety, and you should always have the autonomy that it's designed for. Okay, so that does mean end of life. Like I said, most batteries are reliable if we maintain them, monitor them, and look after them. Okay, so there are systems around that can do that for us. Management systems in particular can even extend the life of it by balance charging it and things like that. But it's a very good system, but it does cost something at the beginning, but can reduce maintenance, reduce failures, and reduce extend the service life of the battery. So probably worth considering. Okay, so we've got to look at installation maintenance, and this is something that unfortunately for life safety systems isn't always done well, and this is important that we try. We must put it in the required space. Most companies will give a guidance of how much space is needed for cooling, for maintenance, repair. That has to be considered. We need to make sure it's cooled, adequate airflow, and we can get the cables in and out. A UPS designed to 62040 is designed to be in a clean, dry, dust-free environment, okay, with a controlled temperature, humidity. The environment does have to be fire protected for life safety, but we get a lot of people saying, well, we used to put the generators in this horrible dirty plant room, so let's put the UPS there. It's not designed for it, and they will fail, okay. The batteries are heavy. We have to keep them at 20 degrees for longevity and for performance, because you will not get the autonomy if it's at 5 degrees. Okay, you won't get the time. There needs to be a small amount of ventilation to make sure we don't get hydrogen buildup in the right type of enclosure to make it safe in the building. We must design for maintenance, okay, to allow access, light and power, and battery management. This is not always done, especially unfortunately on life safety systems. We must consider, so put it in a place where we've got safe working space, we've got local light and power, and we can get in there and maintain it safely. Some of these battery systems are quite high voltage. We're talking sort of 600-700 volts of DC, and we don't want to be leaning over an unsafe battery to trying to maintain it and replace it. Okay, so it's very important that we do that, from day one, that we maintain it in a safe way, okay, and design it to be safe. Okay. So it's important that we do all these things. We're going to put a UPS in there, but it must be monitored. There's no point sticking it in a dirty, horrible plant room and expect it to be working, the next time we use it, unless we do some checks on it, maintain it, and know what status is it in. Very easy nowadays to connect a UPS to BMS actually to the network, and it will alarm out email and can even be remotely monitored by the supplier as well. So we know exactly if it's going to work when you need it. Okay. So hopefully, the learning objectives out of this, we can use UPS as storage batteries as a secondary source if it is designed correctly. Okay, very important. The UPS must conform to 62040, correctly rated to operate the safety services, start them up, and trip the distribution devices in fault conditions when running on battery. Not always done. The VRLA must conform to 60896, must be and should be designed for 10 years at 20 degrees, and really should be calculated for end of life. So when we get to we're going to replace them, it should still be doing the autonomy we require. Okay? And we must be able to support the load for the required autonomy. Okay, or that might be the required number of operations, example for an evacuation lift. Okay, so and we know motors start and stop, and we have to size that battery accurately for that time. And again, not easy to do. We need to maybe have a lot of standby time before doing the autonomy at full load. And how you do that affects the size of the battery you put on. Okay. We should consider that we should be able to recharge the battery to 80% in 12 hours. Okay. We must consider that if we do tests in that building, we were going to discharge that battery, so we will not have the full autonomy, maybe if required. So we should make consideration of that. When are we going to reoccupy? The UPS must be available within 15 seconds. No problem for a UPS. They can be online instantly. Okay. We'll have an ATS locally to the final circuit where the secondary sources come into. Okay. Even if you've got a UPS feed in the final circuit, it might be a requirement that you have an ATS, unfortunately due to the regs. Okay, and then we must monitor it too, so we know the status of it. Okay, the UPS is there as a secondary source, so quite often they're not running the load normally. So there are ways we can get the efficiency up by actually putting the UPS in an offline eco mode. The UPS will come on and make itself available in the requirements. And then we have the guidance in 8519, very important to read that. Okay, and then once it's installed, maintain it in accordance with the manufacturer's instructions. It's a legal requirement. It must be done by an OEM, and make sure that that system is operational. Again, we talk to people writing the regulations, and we help, and we've got, there seems to be a general thing that if you have a life safety, it doesn't need to be tested. It does. Okay, it's very, very important. Okay, so there are other applications, obviously, emergency lighting and medical equipment. There's different regulations around those. Okay, obviously here on the healthcare, we know about the HTM and how to do it, but we do have other CPDs around those specific subjects. Okay, so we're looking for a successful application. We have to specify it, okay, because when you're going to a UPS company, manufacturer, supplier, if you just say I want let's say a 30 kVA for an hour, that's what you're going to get. So you need to specify certain things and give certain information to make sure you get the right UPS application for the application you're doing it. Because if we don't know it's life safety, if we don't know there's motor load, if we don't know we need to trip circuit breakers, that isn't going to be sized in that UPS. So having that specification is very important when you're talking to a manufacturer. Okay. So then obviously you have how many life safety systems there's that manufacturer supplier done, who's going to commission it, maintain it, support it, have we proven the fault clearing capabilities of the systems, what SLAs can we give, have we got a full set of spares available in the UK, not in Europe, and who holds the warranty. Okay, so very important that you understand the application and who you're dealing with, and hopefully you'll choose a good supplier and have a successful installation. So that's brought us to the end, and I believe there are a number of questions to go through.
Hi, and thank you very much, Alex. That was a very interesting presentation and very comprehensive as usual. There are indeed a number of questions, which I'll run through from attendees. One of the first ones is, can a UPS be used for the evacuation or firefighting lifts? And if yes, what should we be aware of while using a UPS for a evac or for such a lift? I think you have covered that, but
yeah, we did look through that, but there's obviously a lot of information in a short space of time. Yes, we have to be very careful. The lifts, a lot of lifts work differently. We need to fully understand the type of lift, the type of motor, the type of braking that it is, so we can size the UPS to start it and stop it, and maybe deal with regen brakes if we have to. Now, sizing the autonomy is very much, if it's for a firefighting lift, we tend to be asked to fully size the UPS for the full autonomy, the 2 hours or 3 hours that's required. Whereas a life safety, an evacuation situation tends to be the number of operations of the lift to evacuate the building and then stop. But we tend to have to do that if we have a 3 hour autonomy. So we tend to do it as a 3 hour period of wait, and then the full load at the end, because that makes the battery correctly sized so we can use a lift at any time during that period. So hopefully that helps.
I think it does, yeah. Somebody else has asked, does it matter what battery is used for life safety UPSs, and are there any specific battery features needed to look out for there?
For a lot of life safety, no, but like I say, guidance tends to look at the valve regulated lead acid, which are a good suited battery. Like I say, we've got people looking at lithium and things like that because they're smaller, but they tend not to be smaller when on long autonomies. So the lead acid tends to be the battery of choice, especially the valve regulated, because it needs less maintenance. And if we're using a healthcare environment for those critical supplies, and we have the HTM to look at, then there are specific requirements in HTM that a battery has to be flame retardant. We have to have it suggests a 10-year battery, and it must have screw insert threads for the terminals. So there are different regulations for different types.
Thank you. Next question is, does the UPS input and output cabling need to be fire rated?
That depends where you're talking. If the UPS needs to be in a fire rated enclosure or room, okay, which is rated for the required time, and then the cables coming in and out of that room need to be fire rated. The cables inside the room won't. Yeah.
Thank you. Somebody else has asked, how many travels of a fire lift are required in battery run time?
Well, that's unfortunately down to the designers to do. If it's an evacuation lift, it's how many times it takes to evacuate that building. If it's a firefighting lift, that can be used at any time and all the time during an emergency situation. So that would have to be sized for constant use for the constant time. So different lifts, different applications.
Thanks. No, we've had a lot of questions. Another attendee's asked, what standards do we need to refer to for lithium Fe phosphate batteries?
Again, standards for these are limited. There is a new regulation, can't remember the number, around, there's different regulations, different parts for stationary batteries, but it still doesn't give us enough guidance around the lithium ion LFP batteries or any lithium battery. So we have to be as careful as we can. What we are finding with the lithium batteries is more the insurance companies are pushing the requirements rather than the standards. So if you're considering putting in a lithium battery, speak to the insurers actually before you do it, is what we're finding, because they are setting up requirements for it above and beyond any standard.
Thank you. Is there a requirement for a battery room to be kept separate from the UPS if kept in separate racks? Are battery rooms to be fire rated?
Yeah, if it's for life safety, all of it has to be able to withstand, the fire for the required period of time. It's often good to put batteries in a separate room, in a separate environment, because the UPS needs an environment that needs to be clean and dust free, but it has a variable temperature range, maybe 0 to 40, as long as it's clean and dry, whereas the battery needs to be kept at 20 degrees. So if we can keep, if it's a large battery, if we partition that room off and just condition it to keep it at 20 degrees, that is quite often a good way of doing it. But it does need to be fire rated if it's a life safety system. Yeah.
Thank you. Somebody else viewing the webinars asked, are there any conversations happening with the within the industry to allow the standards to catch up with regard to UPS equivalents to bulk fuel storage of generators?
Yeah, as you see from 8519, that was, because it was coming out, was put in there to give the industry some guidelines. But yeah, we are talking to different consultants who are on different boards and pushing with things like this to try and make sure it's done properly, because we have the situation that people are building buildings, they're installing life safety equipment, and the guidance isn't there. So we're getting to the point where there's no secondary supplies. We're not allowed to put generators in for environmental reasons and things like that. So we have to do something, and a UPS is, can be used if we do it correctly, and it's very important that we do it correctly. So yeah, we are trying to get the standards up to date, but in the meantime, we're trying to make sure it's done properly.
Thanks. Somebody else has asked, HTMs require us to have fuel capacity for 200 hours for a hospital. The attendee said, I don't think that would be possible to be provided from a UPS unless we're coming for huge space for batteries. How in that case can the UPS be used as a secondary supply for a hospital? In brackets, is there any derogation to be made?
Yeah, 200 hours of fuel is an awful long time. Now, this is where we need to fully understand, is it going to be 200 hours of runtime, or do we need to have the capacity to store 200 hours? Because we're going to be using it for testing and running and then fill it up after a while, whereas batteries recharge. Okay, now this is the problem. I mean, I wouldn't advocate using a UPS for 200 hours, and generators will be allowed in hospitals applications, most of the time. So yeah, use a generator. The generator, we're not denying that the generator, wherever possible, is the best option, over a UPS, but where we can't use it, then we have to do the best we can with a UPS.
Thank you. Somebody else has asked, what are the general problems we might encounter if we use a UPS for motor loads?
Yeah, the general problems we have is that startup current of the motor, and maybe possibly a locked rotor current. So it can be massive, and quite often we get given the startup current as an RMS figure, whereas we need an instantaneous figure to be able to size the inverter correctly, not the RMS, because the UPS is looking at milliseconds of demand. So that tends to be the biggest problem. If we can have motors that have soft start, the variable speed drives, then typically there's no inrush, and we can deal with those much better, which means the customer doesn't have to buy a huge UPS, they can buy a much smaller UPS.
I think on a related subject, somebody's asked, does a firefighting lift require a soft starter inverter to be fed by a UPS?
Yeah, it doesn't have to have, like I said, but it makes things much easier, and it means the UPS doesn't have to be so huge that it can handle all the startup currents. So great if we can have it.
Thank you. If the ambient temperature is quite low, i.e. circa 5 degrees, how much degradation in performance might we expect from the UPS?
It is battery dependent, but we would not be surprised if we lost between 10 and 20% of the performance at that sort of temperature. So it's quite significant. It is
Yeah.
quite. We often put batteries in winter. People say prove it, and if the room is in at 20 degrees, it appears to have failed the test. But in reality, it's passed because it's done the right autonomy at that expected temperature. Yeah, but it's quite significant. Battery performance will improve over 20 degrees. So if we have it at 25, 30 degrees, the battery actually gets better, but it just doesn't last very long. Yeah, in lifespan.
Sure. Somebody else has asked, could the inertia of a rotary UPS assist with large tripping or start current requirements?
Yes. Typically, the rotary UPSs do have a much higher fault clearance capability. However, they tend to be very large, very expensive UPSs, much bigger than the requirement of a lot of life safety loads. So we don't tend to see a rotary UPS being used for life safety. It tends to be very large, multi-megawatt systems for computers. But yeah, I mean, as a rotary UPS, they've got that rotating power and that ability, the same as a generator. Yeah.
As with any such life-critical equipment, you stress the importance of good maintenance of a UPS. One of the attendees has asked, who can carry out maintenance and indeed testing on a UPS?
Okay. But testing can be done by the users. Most UPSs have a self-test function that the users can use to ensure that everything is working correctly. So go along on a regular basis. The UPS itself can have automatic testing. So there has to be no one special to test it on a regular basis, but to maintain it over its lifespan, it should be done by an OEM. It needs to be a company who has access to any updates, software updates, and all parts and consumables that are needed throughout its lifespan. I mean, that was a HSE guidance for the maintenance of UPS.
Thank you. Another question. The guidance suggests 2 hours fire rating of rooms with life safety equipment. This is proving onerous, this attendee said, in refurbishments where the existing building doesn't permit this, i.e. there are existing floors above. Would a best case approach be reasonable in such conditions?
Well, that really isn't up to me to say. No, I mean, regulations say you need 2-hour fire rating, so I wouldn't think you'd get away without having 2 hour. I know it's difficult, but these are the requirements.
And there's another question. Are the loads sequenced on, or do they all operate at the same time?
No, yeah, I mean, good question. Ideally, we would like to see loads sequenced. And if we know that sequence, we can size the UPS to handle the individual startups one at a time, building up the load rather than trying to start all those loads in one big lump. Because again, if you can sequence the load in, we can not sell you such a big UPS. If you want to start everything at one go, we'll sell you a bigger UPS to cope with it.
Thanks, Alex. You alluded in the presentation to sort of lifespan and performance of UPS systems. Somebody's asked, what's a typical lifespan of a UPS? What should one expect?
Typically, we would expect 10 to 15 years of a static UPS. Most three-phase UPSs are designed to have a 10 to 15-year life expectancy, and most manufacturers will maintain a stock of spares for 10 years after the last one is manufactured. So that is typically the range. But I do stress that has to be in the right environment and conditions, and maintained along the line. If you're not in the right environment, if it's not in the right conditions, it could well fail in a couple of years.
Thank you very much, Alex. Thanks for a very interesting and comprehensive presentation on a really important subject for healthcare engineers and healthcare estates personnel. Thank you to all the attendees for attending, and we had some great questions. I hope everybody who's attended has found the event useful. Thanks again, Alex.
Thank you, and thank you everyone for joining us.
Thank you.